Let me start with a question. Why are there so few robots? Robots tackling new tasks generally take 5 to 10 years to develop. And even if you look at the most successful companies out there, like Kiva in logistics, Dusty in construction, or Blue River in agriculture, they took around 3 years to reach revenue. And even if a novel robot reaches revenue, the scaling is often slow because the company wasn't able to iterate the product enough to reach perfect product market fit. So why is this the case? Robots are very complex. Even with advances like ROS, deep learning, or cheap open source hardware, there are a lot of aspects that you need to figure out for every application yourself. And development time scales non-linearly with complexity. Let's go through how this tends to play out. Say you're building a robot to assemble salad bowls. First, you spend a few months speaking with restaurant managers and sketching out concept designs. Once you stop learning new things, you build a prototype. Then it turns out that the two arms are clashing with each other, and you need to remove one and slow down the other. Then you actually deploy it and find out that the operators cannot reach some of the food containers given the kitchen layout, so you need to reorganize them. Then after deploying it for a few days, you find out that it doesn't actually save the restaurant any time because it frees up the person at the counter, but not enough for them to do anything else. And this is even though the restaurant manager before said that a robot doing exactly this will be very useful. So you have to go through the whole cycle again for a slightly different product. And we've spoken with over 100 robotics companies and heard stories like this all the time. So how do we fix this? Technical aspects you need to automate, and for product aspects we need to build faster learning loops. We're doing that with Fabricator. The backbone is reinforcement learning in simulation. We try millions of designs, train foundation models to control them to do the complete task, and then measure product metrics and generate videos. By having the complete behavior in simulation, you can, for all the different designs, you can quickly figure out that what is even feasible and find a design that will actually work once deployed to your clients. So this means removing some of the technical work and creating a faster iteration loop. Here's an example of what you get out of Fabricator. This is wall drilling robots with 3 different arms. Is it possible to get away with using a simpler, cheaper arm? It's impossible to know unless you try it out. And testing it even in simulation traditionally takes a month of work for just one arm. With Fabricator, you get the same in just a couple days for all the different design aspects, which means arms, drivetrains, sensor placements, sensor types, morphologies, and everything else. We're currently deploying this with a few major European robotics companies. Next, we expand Fabricator to simulate hardware and software hierarchically to simulate all-day workflows to bring more learning into faster cycles. Ultimately, we bring manufacturers on board and simulate the interaction between the user and the robot. This is all only possible from the backbone of being able to train any robot in simulation and make accurate predictions. But to make accurate predictions, you need a lot of real-world learning. So from software deployed on robots built by other companies, you can get a lot of data, but you can't do all the experiments needed. You need to be able to do things like, Fabricator says that swapping the wheels on this robot for omnidirectional ones makes the robot 5% faster, but 5% less accurate. Does that actually happen in reality? So we need to build up both of these loops to develop Fabricator further and faster than anyone else. For the experiment loop, we have tile grouting robots. We developed these from scratch internally and are now deploying them with paying customers. That means we have the experimentation loop all the way to actual construction sites. Cool. So why us? Ever since I met Ron at Informatics Olympiad, we've been thinking about how to bring more AI into robotics. Eventually, we realized that the biggest bottleneck is the slow development speed. Then Keith, who I met at Cambridge, brought the construction robotics starting angle. Between us, we have the experience in AI, physics, hardware, and business needed, and are the willingness to learn anything necessary. Now, is this even necessary with general robots coming to market? Specialized robots have a 10 to 100x advantage in value per cost, coming from them being optimized to the exact use case. Economies of scale will not bridge that. But they are mainly limited by the slow development cycles, slowing down their expansion into new applications. Resolving that means robots can be developed at the speed and cost of SaaS and fill up the 20 trillion of manual labor. Finally, why does this even matter? There's 10% and growing shortages across industry, labor shortages across industries and continents. Resolving that means very real GDP growth, but also addressing housing shortages and the rising need for elder care. But robots also open up new environments, like deserts or space, that are not suited for human labor. That fully removes the cap on GDP growth, but also, since industry doesn't need to happen in places suitable for people and other living beings, it removes much of the pressure on the removal of nature. And that's the future I want to live in. Thank you.
Maybe let me start here. A little bit of a similar question than with Centium. For the simulation, is that something you built yourself?
No, we're just building on Isaac.
Oh, on Isaac itself, okay. And the reinforcement learning part, is that just automated, or somebody manually kind of goes in and says, well, when it's good?
So, we have some advancements with foundation models to get a lot of designs to learn very quickly, and how much tweaking you need to do to get reinforcement learning to actually learn. Currently, it still needs maybe a couple days of tweaking for the millions of designs, but in literature, that's usually that much per each design, and we think in the next few months we can bring it to nothing.
So one of our founders is actually building a general purpose robot company.
Okay.
And his thesis is that in the next 5 years, the cost efficiency gap between general purpose robots and specialized robots is gonna shrink, right? And as time goes on, that will continue to shrink. How long do you think that will happen? Or do you think that general purpose robots will always be lagging?
I think it's mainly because it's difficult to make a specialized robot that's really good for most use cases currently. So speeding up the development actually means that specialized robots can get a lot farther. And if you look at the cases where the specialized robots are already very optimized, it doesn't really make any sense to put general robots there. Roomba is most obvious, but even arms at assembly lines, why do you add legs for no reason?